Da, da, da. Oh, hey, welcome to Coffee Compiler Club. Here today to talk about maybe compilers and maybe 20 years of OS updates and Discord crashing and I don't know what else. Yeah, I don't have any open agenda. We're all going to get videoed and show up on YouTube in a little while, and that's done of my spiel. So, anyone want to start, or I'll throw down a short update after I find Matt in my list.
I have something fun to share that I've been working on.
Well, wait, it hasn't been ecstasy for like 6 months. So what the hell is it?
It's been much longer than ecstasy. No, but occasionally I get to work on things at my day job too.
Uh,
So I have a bad habit of like seeing something inefficient and not being able to let it go, or being something where like a pattern that people are implementing by hand that they're sure to screw up.
right,
So
right.
I was seeing some people doing like lazy initialization of singletons, and we were debating over patterns, and I'm like, none of this is thread safe. Like this is horrific. So I went down the path of like, well, how could I make it easier to do? I mean, effectively double check locking.
Right.
Um, and there's all sorts of patterns for doing it. Like the class loading pattern is probably the cheapest one in Java, but that which works well for singletons, but it doesn't work well for non singletons, right? Anytime you want to lazily initialize just a field. So I came up with this thing. So I'm calling it a once, which is a name used in a couple other places. Like you construct a once object with a supplier of the initializer. And like the first time you call get on the once, it will run the thing and give it back. And all subsequent calls to get give you the same value as the first one, or exception if the supplier through, like real basic. But then looking at like hyper optimizing it, like how can I make the once.get call as free as possible? And it's been a long time since I kind of questioned double check locking. And with var handles that came in Java 9, like something really awesome opened up that you can skip the even needing to use a volatile in your double check locking, because we now have access to release fences. So you can store the double check locked value in a plain old field, and after running the supplier and getting the object, you can force a release fence and then store the object. So it gives you the same sort of guarantees as final initialization of initializing finals and constructors. Like even with dirty publish,
You
the
have
object is guaranteed to
performance.
be visible.
You have
And
performance tested this?
yes, it's so one compared to what we were looking at, which was Spring and just like asking Spring for a singleton. This is 1,000 times
Oh,
faster.
not Spring. Just use double
Yeah,
check locking or
right. But
volatile.
compared to double check locking, it's about 50 times faster. Um,
How?
because it's the as cheap as a volatile read is, there's still a cost, right? So this
On
is
an
optimized.
x86, a volatile read is
I'm
nothing.
on ARM.
Well, then I don't know.
Yeah, exactly. I've still been wondering, like on ARM, volatile reads aren't. I guess it depends on it. Reads are freer than they are on x86, so volatile reads are more expensive comparatively than they are on x86. So this makes the cost of reading through a once like the same as just reading a final field. Like there's basically
Okay.
no overhead. And then going further, you can actually optimize out the memory overhead of the once as well with some static helpers. So you get an easy to use model that has zero overhead after initialization. So I'm quite uh I'm
Okay.
quite excited.
Oh, there's no link to this to share to anybody.
That's like it's not open source stuff.
Yeah, yeah, fine.
Yeah, I wish I could share. I've got to push on. We should open source this stuff. But it's cool. I
Well,
mean, in the end, it's like I'm loving var handle in Java 9. Finally getting to use it, quite regularly now. And this is my first time using release fence. But it's like there has to, like, whatever it is that Java does when you initialize a final field, like that magic must be exposed through var handle. So I had to do a little bit of digging to find that. It's like,
hmm.
it's amazing what you can do when you're not constrained by what was available in old versions of Java. So
Final doesn't Final doesn't do anything with any fencing.
it does. So
Ah,
this should have come in Java 5. So if
yeah, yeah,
you
you have
there's a
long.
guarantee, like as you're basically they put a release fence at the end of a constructor if you
Right,
have
which on
final
an
fields.
x86 was a no-op, and that's why
Right.
it was nothing. But no, you're right. There's a fence in there. Yeah.
Yeah.
Which,
And it's funny because the hotspot implementation puts in the fence, but the language specification doesn't require anything quite that strong. So the language specification says you're only guaranteed that your final fields will be visible even if you publish the object dirty. The implementation guarantees that you'll see everything.
Now,
But
Cliff says that no-ops are free on x86. Fences are no-ops and they're free, but every time I do one, it takes the value from AX and it puts it in AX.
well,
So
that's free.
isn't that what NOP compiles as, assembles as? Is a
There's an actual NOP, I believe, but many people use
it's the
NOP
same.
as
It's
a
the same
move.
bits. It's the same bits as exchange AX. I
Oh
thought.
yeah, it is. In fact, you're right.
Yeah.
Been a
Sorry.
long time.
I assume
Been a
those get
long time.
optimized out.
I think an x86 can eat some enormous number of NOPs per second, far beyond the normal count for his wide issue, because somewhere early in the pipe he throws them out.
I'm still trying to get used to the like thinking in terms of ARM instead of x86 and wrapping my head around, like we're doing some transition at my day job again to move more things to ARM, and like performance isn't as good as x86. Like, why would we expect that it would be? Like, well, we have the same number of cores. I'm like, why does that matter? Like,
yeah, I mean, I did this thing with
world.
Azul a long time ago, right? All the numbers changed.
Yeah.
One of the big things that came in with Azul, though, was that all the memory fences and atomic CAS update, blah, 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 things all could hit in L2. And that was I want to say pre-Haswell, and x86 could not. So we had a lot higher performance out of our memory ops than x86 did out of theirs. So that was kind of fun. And then Haswell caught up like 10 years later. And 10x faster clock rate. So,
Yeah, and I don't think ARM has caught up there. And I guess it depends on which architecture of ARM, but like all those things are generally slower.
Yeah.
What's the advantage of ARM outside of like mobile and laptop?
Lower cooling bill.
Yeah. Yes, I've seen that too. Lower power in a server configuration.
I mean, isn't theoretically I was going to say the cost, because the licensing stuff is, I believe, less ridiculously expensive compared to x86.
But I thought the licensing thing was just who can go make it. So there are multiple makers of ARM chips.
Yes, but I believe, sorry, if I remember correctly, the cost you pay for the x86 license, assuming you can even get one, because I'm not sure.
I don't think they're doing that. Is there anyone other than grandfathered AMD that can make
x86s? I think in the past there were a few folks, but I think it's just AMD now, and it's only to keep them from getting hit with monopoly.
Right, and it's like Intel licensing, but either way, so there's that. And I would imagine if it was possible, it would probably be you would need to pay a fat stack of money.
Oh, okay.
Whereas with ARM, they're typically a bit more. I don't know if permissive is the right word, but they're a bit more open to licensing it out, because that's kind of their business model.
Yeah. Okay.
Chips. ARM doesn't make anything. Like, they're an IP licensing company.
Yeah. I certainly got sold, or people try to sell me on getting ARM supercomputer-like things that had a huge count of ARMs in a small box. While I was at H2O, so they were in the low power, high core count long before x86.
Yeah, I think so. In terms of performance, I think until maybe a couple of years ago, I think it wasn't that compelling because it was mainly used in these small embedded boards. But then it started picking up on servers where Amazon, I think, was one of the first to start with their what do they call it, Graviton servers or something. And then Apple came in swinging with their with their M1s. So I think we'll start seeing more ARM on desktop environments in like the next 5-10 years.
Competition.
Unless RISC-V suddenly wins and takes over everything, but we'll see when that happens.
Yeah. Yep. All right, new topic, maybe. What was I gonna do here? No, I had. Go ahead.
Update.
Yeah, update. That's what I'm heading for. I grabbed simple just right prior, but now I want update, which is here. Here, yeah, right. So, all right, yeah, right. So sometime last week I sorted out mutual let rec having to do requiring to do a cycle finder. I have to actually find the cycles to get the mutual parts to be mutual. That I got done in the side branch using an AST, and once the AST got sorted with the cycles, I could then do the standard Henry Milner mutual let rec thing correctly, and you didn't have to write your code in cycle order. So that was nice. Followed by, I was still trying to figure out where I was getting sort of evil self-recursive behaviors between the way I was shaping my program in AA versus what I was getting out of this AST branch I've been working on. And the difference is how to handle the environment variables. And I've been doing closure converting forever. Like I have an operational model for AA where I convert something that looks like C-like code actually being functionally typed using closure conversion. Okay, well, my closure conversion setup wasn't sort of the canonical one, and I wasn't sure where I was getting into trouble, but I was getting people to be self-recursive in places I didn't expect, and then that bound up their types to be, you lost your let polymorphism. Anyhow, I sorted on that for a while and got simpler and simpler test cases, and suddenly realized where I got it wrong, and got a bunch of test cases working now that show how to do the mutual, not the mutual recursion, the closure conversion, and could still get all my proper strong typing games done and do it in the graph style. So I don't have the graph style piece working, but I have test cases that I think now I can turn to the graph style. And the main sort of interesting thing that I was falling over was I actually have self-recursive structs that I'm typing, same like self-recursive functions, like factorial is defined in terms of itself. Well, I have structs and defined in terms of themselves. And it's like the same piece of work that you do for functions you do on structs. It's like a tiny change. I'm trying to think if I can throw out any kind of example that makes any difference here. Let me bring up, why are you doing this to me? How about this guy? How about this guy? Now let's share you. Share the doc. No, I don't have a test case ready, so it's all clunky and slow while I throw something together. Whip down here. Let me go find, I think I kept one of these lying around. That's one of them. Oh, here we go. Let's see if I can work forward from where I came from to where I'm going in a way that's readable. No. Recursion. Yeah, clunky, so. That's probably not terribly readable, but maybe it is. So let me do this here. Let me see if I can work through what hell happened here. No. I'm
Can
getting
you
formatting going
increase
here.
the font? It's not
Oh, font size. That's why.
a little bit.
I started this window up and like normal, and it was super big. And it's like, why is it so big? And I put it back to normal size. And the answer is you can't read it. No, where's extensions? Code blocks, fucking start. Yes, why are you not starting all the time? Now highlight, Control C. Yeah, format, see if I can do it. Maybe. Well, that didn't help any. Wow, it made the comments harder to read. Yeah, fine. Okay, so what the hell's going on here? Well, I maybe have one earlier version that might be even better. No. Everyone stare at this one. No, this one's going to be uglier. Okay, so I'm busy trying to write something in a type lambda calculus with functions and structs, and also I can, because it's simply type, I can just execute it and type it and execute it. So it's not got all the things that AA's got going on it. So there's a lot of shortcuts going on in here. And the main key was I was making. In AA, I have full closures, which meant, practice a fat pointer. They got a code pointer, it's got an environment. So here's an explicit code pointer. So A here is an explicit closure. The closure has some code and it has an environment. And the code in this case is a stupidest possible self-recursive call to A. So somewhere in here I have call, display, that's environment 0 if you like, A. So here's passed in. So in the way this works, closure conversion works, is you take your normal function, like if I was to write this in a more AA style, I would say I have an X, and I would say random, however random comes from, and I wanted to call A of X or X. And so this is an identity call that just, it has self-recursion in it. And it's the simplest possible self-recursive function I can come up with, the goal being to just make my life simpler when I'm trying to debug where my types go sour. And so I've rewritten in this other style here where I have an explicit closure. There's an explicit function that says X and if random and call A and X, but it's hard to piece out the parts. So there's an explicit display or environment being passed in. That environment is used to load the external variable A. And so the nature of this means there's no free variables in this code block. And instead, you're going to pass this environment, which is the stupid one that contains just A itself, into the code whenever you call A. So somewhere down in here, I'm calling A with a float, and I'm calling D, which calls A. And here's D calling A with a 1. So with an int. So A is forced to be polymorphic. It's called with an ints or floats. And I'm trying to diagnose where my types go weird on me. And one of the things that happens here is you can organize however you want there is and the call thing is just a little helper function can go away and you expand out things a little tiny bit. It might help, it might not, I don't know. This call here basically says, oh, it's going to be disp0.a.code gets called with disp0.a.env and the X. So I actually am calling the code block with an environment and an X. And that's called just a short helper for that. So I don't know if that helps read that or not. Anyhow, the trick isn't there. The trick is here. There is a reference to A up here. Okay, let me go write that again in another style. What did I say here? A is a struct which has a field whose value is A. What's that type? And there's your problem. Well, it turns out the type's pretty simple. The type will be, it's a struct, but I got to give it a name here. So the T is going to be a name for a type, and the type is a struct type, which has a field whose type is, well, T. That's its type. So it's a self-recursive structure type as opposed to a self-recursive function type. Turns out I can handle this, been handling it all along. I didn't know I was getting to it. Didn't understand I was getting to it, and that's where I get myself twisted up. You get your undies twisted up in a knot there. And the bug was basically trying to define in the environment scope both A and D, but D needs to be polymorphic with A, or needs to use one polymorphic value A, and A is itself called external A down here at the bottom with another polymorphic different value. So I can restructure this code, which I've done so in a later example. How about now? Cow 16. Yeah, this one. Oh, that's we can do one easier. So here's a slight variation on the same code. I'm gonna throw it down the block here, and this is time to compare and contrast. And what I did here in the top one, I have the closure is foremost. In the bottom one, the environment is foremost. Embedded in the environment is a closure. Oops, is a closure A here, which is a combination of code and inv. So what this means is I have an environment, which is like a stack frame. I have a stack frame. I've defined an A variable inside of it, and then I make an A closure out of it. It's a code blob with a closure. And then I have a separate environment for D, a separate stack frame for D. These are all side by side. In any reasonable C program, you just combine stack frames and say, here I have A, And it's a function that takes the self stack frame, and here I have D, and so it takes the self stack frame, which references A, and I can pull up A out of my own frame. It's just like a local variable and then execute it. Okay, that's the goal, except that in the typing land, those two environments variables cannot be shared together, because if you do so, then they tie themselves in a knot because each environment variable is itself self-recursive. So that was my AA bug for the last 6 months or more, where I didn't understand where I get myself twisted, and I kept making simpler and simpler execution engines of what I thought I was doing, only to discover, oh, this is what's really going on here. So this one, as it stats, the bottom one here, as it's stated, I have two environments, but my expectation is to have one, because I get one stack frame. And you would do like this, and I don't need that variable because it's just the one stack frame. And now I have two closures, and they share the same stack frame, the same environment. But now I lose the polymorphism on A, because within this environment, D calls A with an int, and it forces.
Is it fair to say that NFAD is the enclosing scope,
Yeah,
if you
it's the
will?
scope. It's a stack frame. It's a closing environment. In a classic lambda calculus sense, that's your environment.
Mhm.
It's a list, it's a mapping of variables to values. And the map
Okay.
is, A is mapped to this closure and D is mapped to that closure.
Mhm.
And it is just identical, like semantically and equivalent in all normal ways to a stack frame, or at least that's what you want. You lose that equivalence if you begin upward exposing variables, and then you have to actually allocate frames in the heap instead of on the stack.
Mhm.
In this kind of simple code, it's all a stack frame, and any good, Haskell ML compiler will make one stack frame. And
That stack frame, if you will hold all the free variables, all the not free all the bound variables for the closures.
right, A is a
And
bound
that's
variable
so
for yeah.
yeah. So what this it will hold all the variables from all the closures, so it provides the scope for them, if you will.
Yeah,
from the-
yeah. And in this case, this program now no longer compiles, because the combination of using this environment by D here, where he grabs the A's environment, which is the same as the D's environment, forces A to accept an int and it's no longer an identity function.
Mhm.
It becomes a function that maps ints to ints. And therefore passing a float here fails. Whoops, passing a float here fails.
So okay, I kind of see the problem. Yeah.
It's like you could take this code and translate it into your favorite Haskell or ML strongly typed functional language, and somewhere in there it'll hand you the types for that. I can get you the type printout that I get out of that. It's pretty brutal after the cycles are all closed. Whereas if you look at the top one, it's clear that A remains an identity function on A, remains an identity function. And then therefore it can be called with a one, it can be called with a float, and an int and a float, and life is good.
So
that's
the
what
purpose, the purpose here is to not hold if this is a stack frame, if you want to free it as soon as you leave the scope. So not is that
The purpose here is to not have two stack frames. Let me see if I can undo. Yeah, so here I have the functioning version. This is the stack frame. I got one more undo here for A here. The stack frame at the top just has A alone.
Yeah.
Then I have a stack frame for D. He has a back pointer back to the stack frame for A.
okay?
When you do a standard C style compilation, if you've called A and then somewhere in the life, I guess main would call D, the D has got called from the A's environment, so he has a back pointer up to A, and that's just your stack pointer at negative a fixed offset. Like it's a straightforward what you would do and see if you could get outside your local scope. Plenty of languages do that as a hack or as a way to make these things go efficient. But I was just saying, in this case, I want to, what happens if I fold A and D together? If I write this in a more natural style, I would get them folded together in one, there'd be one stack frame. So here's the more natural style. Somewhere in the world I've said main, and I got this, and down here in main, I've said A is a function that takes an X and it calls random math.rand. And if it's true, I call A of X, and if it's false, I call X, and I'm done. There's A. And then I say B is a function that takes no arguments and calls A with a 1. And that's what D is. And then I'm going to return, I don't actually have a return in AA, some struct, some pair of things. And one of them is an A with a float. And one of them is the other half of the pair is just calling D. So maybe that's an easier to read result. I'll add some semicolons for fun. And there's one stack frame for main. You define A in the stack frame, you define D in the stack frame. You call the A function you just defined, you call the D function you just defined, and you return the pair. Okay, that seems obvious. So I'm expecting one stack frame that contains both A and D. Turns out that because A is self-recursive, he has to have himself being his own stack frame, so he can find the reference to A. It's a for reference. And if I include D in there, then that ties up A's type to being it takes an int. So I need to have them for typing purposes be different stack frame equivalents, different environments for typing. But there's an optimizer job in the end that says, oh, I've got a bunch of stack frames in a row, and I'm just using them to collect things together. They don't have any dependencies any other way. So I could, it turns it from a typing problem to an optimization problem. So I need to give up on typing it as a single stack frame, which is what I've been doing all along, and say, no, I need multiple stack frames for typing purposes. And then it's the optimizer's job to say, no, you're not doing anything stupid here. You don't have any upwards exposed functions. I'm just going to fold all these things together.
X here is polymorphic.
Yeah, it's polymorphic. Yeah. Standard polymorphic variable.
T to T, the identity for.
Yeah, it's an identity call.
Let's say, so the identity
here.
Yeah,
put a.
Here.
Yeah, put a.
T.
We'll comment this here just so it's not. There you go. Yeah, both of us did it.
Sorry. Okay. So here is the X, the A is instantiated to int. Here is instantiated to float.
To float.
So,
yeah. Right. I mean, I might as well put where you got the float there. You put a structure that contains a person with a name and an age, whatever. Right?
Yeah.
That's polymorphic. It's an identity call. Anything you want in there. So that was my typing grief sorted out this last week. So I'm still sorting typing things out. But this time, well, of course, I've said that 5 times in a row, 10 times in a row. I think I'm getting there. Still feels like progress to me. So that's my summary.
Okay. Cool.
Now I owe Cameron some time and I owe Simple some time. So I'm going to set AA aside and go do other things. So I'm like mind sharing between 3 projects. And the cost to switch is kind of high, so I switch occasionally and run a long time and want to go well 3 or 4 days. So that's where it's at. Java Lang invokes switch point. I'm reading the comments, the chat. I don't know what that one is. All right. Enough
Next
type
topic.
theory to make your head spin. We're all done with type theory.
Someone got a topic?
Yeah, very quick, or I'm gonna say, yeah, okay, I have to go early today. Simon, you gonna give us a summary for a status update for you walk?
Next time, maybe next time.
Next time. All right, fine.
Goodbye.
I have been wondering why Azul has a Clang compiler for Java, because I thought the Java compiler would just always beat like the Clang version.
Oh, that's the business. Well, Arthur.
So we are using LLVM for JIT compilation in runtime. So Java code is compiled by Javac, and we get bytecode and we execute bytecode. But in our hotspot-based VM, at some point we replaced C2 with a LLVM-based compiler. And the reason for this is, it was harder to maintain and evolve C2. It was easier to do this with LLVM. It was easier to find compiler engineers who know LLVM. There are trade-offs. Yeah, it is like slower in terms of compile time. That's probably the weakest point of the solution, but we get great performance out of it. So at this point, we are beating OpenJDK C2 like across the board comfortably.
Nice. And
Do you know why you're beating them? Because when I compared Clang with GCC was always beating them, and I figured that Cliff has written compilers faster than GCC. So I was a little surprising to hear that
you
the
have to watch
Clang
out
version.
which performance beating you're talking about. C2 compiles faster. He's talking about
No, not compile time. Runtime performance.
Yeah, right, runtime performance. Yeah.
Yeah. So do you know why you're getting better runtime performance?
So there are a couple of big things, like more aggressive and more like smart inlining, escape analysis, but also there are a lot of smaller things. Just at some point, you won't get great improvements from single optimization. It will be dozens of individual optimizations that together just give you better code.
Yeah, when I was talking to Gil years ago about the LLVM choice, he said, look, I go away for a week, I come back, I pull the latest LLVM and we get a 1% performance increase because there's, 100 people out there writing people optimizations for me that have no idea that I'm using their code, so it's just how many people are working on C2, 6, how many people are working on LLVM, 100. It's just a different order of magnitude.
But from what I gather, the LLVM API changes constantly. It's harder to.
Yeah, we
no, not constantly. It just they don't care about breaking people that already use it. Yeah, I mean
they don't maintain backwards compatibility. Okay, that's
there is some maintenance burden. We have a fork which we update. Like there is a constant merge process, and we pick up changes maybe multiple times a day if there are no conflicts. And yeah, things break when they change APIs, and that's the cost of getting these performance improvements, kind of quote unquote for free. Another example, maybe when they are not doing this focused work on what we care about, the performance improvements they are not that huge. But for example, new hardware architectures like AVX 512, we didn't have to do anything. It was done by Intel folks in LLVM upstream. Like, okay, we had to do a few things in intrinsics here and there, but we got support. Like ARM, porting for ARM was, it was there in LLVM. We needed to maybe port some things around save points, around lowering there, but everything else was there, and it was of a pretty good quality.
Do you know what percentage of increase you get using the LLVM compiler, like compared to just using C2?
This is a benchmark question. What benchmarks are you getting numbers out of?
Yeah, because he said across the board, so I was wondering if you knew the percentage.
I would say on our standard set that we track, there are something like 450 tests maybe. If we compare against OpenJDK, I think our win rate is something like 90-95%. And if we take geomean across all these 450 tests, we are something like 40% ahead.
Wow.
So in terms of margin, how much by which you beat C2?
Well,
what?
Some big wins and some of them at least. Some really big wins.
So yeah, I would say, of course, this set of tests, there are some like bigger benchmarks, there are some micro benchmarks, and on some of the benchmarks, it's easy. I don't know, you take Stream API benchmarks, and it's easy to show like X-fold improvement because you are able to like strip all the boilerplate away and boil the code down to the actual semantic of it. I would say when we are talking to like real pilots and customers, they're usually looking for improvements of like 15% and more. So if we demonstrate 15% reduction, and usually it's not just pure performance, is they they can use 15% less of, like, I don't know, number of servers in their cluster to handle the same load. That's when they are happy, and that's when they buy.
Wow. Yeah.
Yeah.
I still feel a little funny that LLVM was able to give you such an improvements because not once have I seen them beat GCC. So
But
this is weird to me.
As a data point, I work on C++ compiler and then regularly see LLVM beat the GCC. Very, very, very common and very, very large margins. Not always, but common.
Yeah, I think there are. I forgot the name of that website that constantly benchmarks compilers. And every time
Horonix.
yeah.
Horonix.
Every time they benchmark GCC and LLVM, my summary of it when I read it, well, it's a tie. Like, there are workloads where GCC is better. There are workloads where LLVM is better.
If for my workloads, it's always GCC always inlines a little bit more, and I get like more than like 2 or 3%. It's like roughly around 5 sometimes, or higher. But yeah.
Also, keep in mind that we have quite a few things that are downstream and Java specific. For example, inliner is completely different. Like, we are using inline cost analysis from upstream, but the overall inliner and how we do this is different.
You folded in profile data into LLVM somehow. You were talking about that.
Yeah, and LLVM supports this. It's not the standard run. They need to compile with PGO to do this for C and C++. But yeah, we feed profile information, and yeah, this obviously is a big contributor to the overall performance.
Makes sense. So you're thinking you're getting 10 to 15% what people will care about. So some of the benchmarks sound like you get some wildly big numbers for better inlining, which I can totally get on, especially on micro benchmarks. But on clients, you're still getting like 10 or 15%. The customer data.
Yeah, I would say if this is above 15%, usually it's a smooth deal. If this is below 10%, our sales engineers would come to us and ask to help.
Yeah, what can we do here?
Yeah, and both happen. So you can, you can use this kind of 15% as a
interesting
rough mark.
Back in the H2O days, we routinely had issues. At 10x, you had a speed up, you had a smooth sail. Below 2x speed up over, R or Python on their current hardware, they were kind of less interested. That was the ratio of numbers that were winners or losers. And you're at 10, 15%. It's a much tighter spread. It's very interesting. I guess it's a much more mature market. The numbers aren't going anywhere. So 15% is just cash off the top, straight up.
I think it also took us a while to to position these improvements in the way that we can actually sell. Because if it's just 15% improvement in performance, I don't know, your batch job is now 15% faster. It's harder to sell because, well, engineers will be happy, but they need to go and convince their business to spend money.
Yeah, it has to come off the bottom line somewhere.
Yeah, so the way we currently position ourselves is it's cloud cost optimization.
Right.
You have your Java deployment. You are spending X amount of money on cloud. By using more efficient VM, you can reduce this. And suddenly it turns this into a money problem. And people who are in charge of money seeing the calculations, like, okay, we are signing.
Yeah, right. Yeah, they can do the math, and it's not this ambiguous. My engineers are happier. Do you have anything to do with better latency issues, SLAs?
So this is historically what we've been selling to, but this and we still have good number of customers of this kind, but these kind of deals tend to be smaller than these cloud cost optimizations, and B, OpenJDK is catching up. Like there is ZGC. It's they have now generational ZGC, and looks like it's a matter of time until they get to the point where where OpenJDK is good enough.
So cloud cost instead.
Yeah.
Yeah. Okay. Sounds good.
And
that
yeah,
validates XDC's business model somewhat.
I kind of wondering if you guys offer any tools to help detect like ways to make their code faster.
A better profiler.
Yeah, because I figure profiling and runtime is part of the compiler, and I mean it can be part of the compiler, and it would be like the easiest way to detect problems.
Well, it's a different kind of profile. I think there are constantly talks about it, like how can we feed this information to the developers, like maybe from the profile, maybe from the optimizer, and the optimizer says, well, I couldn't vectorize here because you did this. But no, we don't have anything specific here.
Okay, because I've been thinking about doing something like that for a while, but it's just I got to finish my compiler and a bunch of other things before I get to it. So
Levo, the Java market's dramatically different from the C++ market when it comes to profiling. So basically, it's Arthur's job to make sure that no Java developer ever has to look at profile data. Even though that's not what Arthur sets out to do, that's what the expectation is. The idea is, you just have someone slinging piles of code, and somehow the VM makes sense of it and makes it actually run decently. And there's a mindset like that in the industry, in that part of the industry.
Yeah,
that makes perfect sense. That makes perfect sense. And Node, that reminds me of V8s and Node. Like people want to write their JavaScript, they just don't want it to be slow. So V8 just puts all of their met effort into that, even though you're always going to get disappointed at the end of the day.
All right, Arthur, you wanted to say something?
Yeah, people run so much code that they don't have control over. It's just dependencies over dependencies over dependencies. So rarely they can do things there in some downstream libraries they depend on. We have some customers which have actually dedicated performance engineers who care and who we constantly talk to, and they would ask various tips and tricks how we can understand things without bothering you. And on this kind of individual basis, we basically show them the things that we are using for troubleshooting. And some of them you can use even without having compiler expertise. But quite often, I think the kind of learning curve very very quickly. You need to understand what the compiler is doing pretty well in order to make use out of the information that we have. We can give them, I don't know, the IRs and the tools that we use for visualizing the IR, but it is for compiler experts. But sure, you can see why some optimizations are happening, why not happening, what you can do to change this. But it's not for a typical Java developer.
Certainly, I did the Adazul did the hack to expose the hotspot internal profile data. I kept finding engineers that were terribly excited to see this stuff and then could action on it. But I'm sure you're right. The vast majority have no clue. Yet another management bean importing another open Apache JDK Commons, yada yada yada.
Mm-hmm.
Miles and miles of crappy code. It's not how I thought the industry was going to go. That's for sure.
It's not so much that it's crappy code. It's that it's overgeneralized, under optimized, and and it does what it needs to do. And when people are looking to solve that problem, they solve it in 5 minutes instead of it used to take us a year to do the same thing.
Move the problem to the data center, burns more power or runs slower, can't get your
Yeah.
time to.
Well, and what happens is it's kind of the big O problem, right? Because, you know, if you're only using it at the edges, it makes no difference how inefficient it is, right?
Yeah.
But then you make the mistake of using it in kind of your, whatever that core transaction
moves
is
into
that
the
makes
core
up.
path. Yeah.
Yeah, and then it gets really ugly. But you know, that's why Arthur makes his money.
Okay, fine.
Yeah,
There you go.
it is seriously magic though. I mean, optimizing compilers today. Yeah.
At first, I believe it's always shipping features, shipping something that you can draw on later. And soon along comes a company, like in Arthur's case, that offers you to run it more efficient. So that's the business case here.
Moving from efficiency.
Just an idea. I'm not saying that people should do this, but is there a reason why like Oracle or Red Hat or somebody doesn't offer some kind of optimized open source library, or it doesn't even have to be open source, but it's a kind of optimized library that people could just use instead of depending on 100 different things? Because it sounds like that could be like an easy win. Like you get better documentation and you don't have 100 dependencies.
But they have the one step higher. They have the JIT, they have the bytecode. They can.
But it's even worse though, Levo. It's the XKCD where it's like, okay, so we have these 14 competing standards and they all suck. So I'm going to solve it. And then, you know, the next frame is, you know, the problem is we now have 15 competing standards.
Yeah.
So basically what you just described is that, and no one ever agrees on
What should go in that super optimized library?
Yeah.
Doesn't if Java supports like has a library, don't people normally take the one that's built into the Java?
Java doesn't have a library.
Uh,
Java has the standard library that comes with it, right?
yes.
Yeah, that's what I mean.
But it has so think of it like this way. C++ has no libraries, right? No standard library. There's you know, like
there's STL.
Kind of. I mean, it's still a joke compared to any language that has a library. So you have C++ with, say, on the order of 1. You have Java, which is kind of the middle ground now, which is like on the order of 1,000. And then you have NPM, which is, you know, on the order of 12 trillion. You know, so it's like
just beyond the beyond.
Yeah.
You don't get all the libraries you're looking for, everything out of the JDK. So then there's Apache Commons and Google Guava Juice and God knows what all as fairly common, fairly standard-ish libraries.
Yeah, and generally, you know, most of the libraries are pretty good. You know, if you look at them in isolation, they're pretty good.
As a library, yeah.
Yeah.
Does it solve your specific exact problem? No. Does it take a chunk out of it? Maybe, yeah.
Yeah, you usually get into trouble over time when you just have too many of them in the mix.
If you keep letting them come in, yep.
Hmm.
Well, I don't have security, so I'm going to pull in security libraries. And shit, I'm terrible at HTML, so I'm going to pull in Vue and Apache Commons, whatever, or React, Angular, this, that, and not too long later, you're looking backwards at 20, 40 Java libraries. It's down from NPM would be 3,000, but you're still, you know, you're well past where you can make cross library optimizations make sense. People look at what's already there and they grab bits and pieces from everywhere, and suddenly you don't have any high level.
But that's actually why Java did so well, is because the VM could do cross library optimizations, and you couldn't do that. You couldn't do that in any other language at the time. You know, C2 was the first thing that successfully did that.
Okay, what do you think about that? Sure.
To this day, as I said, one of the bigger optimizations was just more aggressive inlining, and that's how you
better inline, yeah.
And that's closer and to be able to optimize across these abstraction layers.
My biggest regret with C2 was the too early suck inlining. Inlining sucked because it was too early.
So the other thing, you know, C2 did early on, it beat C++ in performance on encryption decryption benchmarks. And the reason is because the library doing the encryption decryption, most of it could be inlined at the use site, but C++ couldn't do that because the library was a DLL. So, you know, basically C2 erases all the all the thunk overhead of a DLL. And, you know, so even though Java was probably 40% slower than C++ at the time, it was still like 3 or 4 times faster in the encryption decryption benchmarks, which is pretty crazy.
I got hammered on those, so I went and did stuff. There was this weird thing. What was this stupid story? Somebody somewhere flipped not the C2 team, but the runtime team put out a 64-bit patch to use 64-bit ops on Spark at the time when x86 didn't have 64-bit ops. So it had pairs of 32, and to do that, he made register pairs in the allocator, which the allocator was doing register pairs, so that was fine. But if you looked at 32-bit on a standard 80 wasn't 886, it was 386 or something. It was somebody who didn't yet have 16 registers. So you had 7 registers, BP, I freed up from the stack frame, so you got 7. But if you paired them for doing long math, you had 3 pairs. So you had 3 registers when you did long math after this hack. The prior hack was I broke longs up into 2 separate values and treated them as 2 separate values, and you had add with carry and subtract with carry and all that kind of shit directly in C2. And that gave you double the register count because you had 6 or 7 instead of 3. And most of the crypto work was done with big integers, which mostly did shit where they left shifted and right shifted 64 bits by 32 and masked and or masked and would load along and mask the higher the low half. Well, I just ate those into direct loading the higher load word into one of my 32-bit registers. And so the non-64-bit x86 flavor was a good twice as fast on this big integer crypto stuff over the thing the runtime group did. And they didn't have they had a bunch of other issues with that. So I told them to stay in their own bailiwick and reverted that one. And we waited.
I'm
64-bit.
I'm still a little confused about that. I thought the problem was the lack of registers, but what was the actual problem?
No. So I'm going back in time. You're comparing an x86 of an era 20 years ago with a Spark RISC chip of an era 20 years ago. x86 had fewer registers and typically clocked as well and did enough out of order things that it was reasonably faster, or at least highly competitive with the RISC chips. Now, C2 was designed well on RISC chips to handle them well. And so, the difference between C2 and C1 was 50% on a RISC Spark.
I meant the 64-bit pairs versus.
There were no 64-bit registers back then. You only had 32-bit registers. Spark got a 64-bit register set ahead of x86 by several years.
Maybe I misheard you, but I thought the pair hack was slower than just using 32 bits. That's what it sounded like.
Yes, I said that. You got it right. The pair hack was much slower on an x86 than using.
And it wasn't because of lack of registers. What was it?
It was because of a lack of effective registers.
Lack of 64-bit registers combined with the fact that there were so few general purpose registers. Yeah. So you would run out now twice as fast because you had A through E, right? AX, AX, BX,
EX, DX, EX.
And then EAX.
And the EAX came along. Then maybe it was right. 32-bit was EAX.
It's 5. Yeah.
And then SIDI.
Right.
That was your 6, and you had BP. That was your 7.
BPSP, right?
And then you were out. You had 7 registers. And then if you could pair them, if you had to pair them, then you had an AB pair and a CD pair and a DI SI pair, SIDI pair. That was your 3 registers using 6 of the general purpose. You had 3 effective registers. And if you only needed half, you would load twice the low half and the high half as a singleton from the C2's point of view. And that got you a full load of 64 bits and 2 registers. And then you would ignore one because you only wanted the low half.
Okay, I think I see the problem now. It's because you're loading twice as much when you didn't need to.
Yes, and you spilled twice as much because you spilled all 64, and you spilled twice as often because you only had 3 effective registers instead of 7.
Yeah.
So it was a huge loser if your long math looked like take the high half, take the low half, shift this guy and these, or add these together, take the carry, take the next guy, take his high half, add your carry, add the low half, and add, and you did things with 32 bits all the time in big integer. So flipping it to 64 bits was just a loser. Fine. So eventually he got actual 64-bit registers on the x86, and eventually he got double the count, and now double again, and double, whatever. Fine, but back then, you know, the giant loser. So roll it back, 32-bit math.
I always been wondering how are the Java compile times? Because I mostly did C++ and C Sharp.
Java
C Sharp is just like Java. C Sharp is Java clone. So
Yeah.
just every question you have about Java, just remember C Sharp, and that's your answer.
Yeah, except that their C2 version was never as good as C2.
Well, they never had a C2. They had C1.
Oh, there you go. Okay. Yeah.
The magic number I had seen in Java C is in order of tens of thousands of lines per second.
You're talking about Java C. Yeah,
Java
so
C.
asking Levo. When you say Java compiler, it's Java C to bytecodes or bytecodes to machine code. There's two different compilers. Which one are you talking about?
Yeah, I want to know about producing it to a jar, but for C Sharp, I remember at work we had a bunch of DLLs, and it would take many seconds to load the many DLLs. But compiling, it was basically like just a few seconds.
Yeah, it's roughly the same. It's C Sharp and Java. C Sharp is a clone of Java.
Hey, Matt,
But
throw in the
people,
83, 86 registers, maybe. He threw in an 80,
80 because of registers pairs. So it had 7 8-bit registers, A, B, C, D, A, H, and L,
Yes.
but you could pair them up to that 16-bit registers. So you could get register BC, which was paired up of 8-bit register B and 8-bit register C.
It was BC was their pairing, because I had a C
Thank
that had the
Thank
similar.
God I never
Oh,
had
yeah.
to work on the 8080. That's
At
awful.
least one advantage is that memory was probably closer to one CPU cycle. So you
Yes.
probably wouldn't lose as much from spilling.
Yes.
Yeah.
Relative speed, yes. No, but go find. I never did hotspot on an 8080. I did
Well-
hotspot on a early x86. I want to say 286 or 386. Pentium Pro was the first public version. I
Yeah,
was working prior to Pentium Pros.
Because from the 8080 to the 8086, they changed it. Instead of doing the pairing like that, they
Yeah.
introduced the X. So you had AH, AL, and AX, for example.
Yeah.
And then
Extended registers, right? Whole
Yeah.
16 bits.
All 16 bits, yeah. That was the right. And then by the time I started doing hotspot, we were 32-bit. I want to say we went straight to 32-bit registers. There may have been a 16-bit.
there was a 16-bit backport of C1, I know, because
Okay,
they
yeah, that's what I
had
was
to
thinking there
support
was.
Windows 3.1.1 for work groups with Internet Explorer or whatever.
Oh God. Okay, fine. Yeah.
Anyway.
Yeah. The C2 never did the 16-bit register thing.
It was if you had to work in 16-bit Windows, it was just pain because you had 5 different memory models. You had the large.
Oh God, yes, I'm far.
Medium.
There was
I can't even remember.
A large.
Yeah, I can't even remember all of them.
Right. And I totally hacked in there, but that was pre-Java days. That was my 4th, 5th days, and a lot of C compiler stuff.
Yeah, so basically every library you used had to be compatible with whatever compiler options you used for memory model. Because if anything got mixed up between, let's say you had 60 LLs that you were using, like this is why nobody had libraries for Windows.
Oh yeah.
Like nobody realizes that now, but back then,
yeah,
the only DLLs you used were the ones that came with Windows or the ones you built yourself. And that was it. There were no third-party libraries.
Statically linked everything else because you were going to suck with the wrong DLLs.
That's right.
Hey, Levo, yeah, people pull in Java libraries. Instead of DLL hell, it's Java library, jar hell. You get
if they're all dynamically linked.
The jars, no, the jars don't get pre-linked. They get linked.
No, he asked if they're dynamically linked. So this is what Cliff refers to as class loading. So instead of saying dynamic linking, Java says class loading.
Yeah. Yeah. Okay. Yeah. Fair enough.
So basically it links one thunk at a time.
Class. Yeah. Yeah.
Okay, so it sounds like the build times are not horrendous because people told me that it can take 20 minutes or 30 minutes, but I've never actually seen it.
Yeah, you're talking apples and oranges here is the issue. When you start a VM and he begins doing the dynamic link thing of class loading, that's plenty fast. It's not infinite, and there were some times when 1,000,000 lines of code would get run before main that all got class loaded and sometimes JITted and optimized and shit, and there were some complaints made that got tuned down somewhat. So it's not so bad now I get to main, but point being, your load 10 jars, the jar has hundreds of classes each, you get tens of thousands of classes. The
And it's a
actual
tiny
loading and
fraction of a
linking is
second.
pretty quick.
Tiny
sorry?
fraction of a tiny fraction of a second.
Yeah.
It's ridiculous how fast it is.
Yeah. So
Okay, yeah, because I was just wondering, because when you're building, it seems like even if you didn't change a class, you would still have to rebuild it if they belong to like the same project or to the same.
no, strong typing, and if the types match, you're good. And understand the difference here in the linking steps going on here. In Hotspot, when a class is loaded, that's like a disk file into memory. It's like nothing. When you link a class, all he does is he confirms that everyone has the correct signatures across the board. Now the interpreter can go run straight up, but you're running at interpreter speeds so that you didn't go patch this jump to that jump, make this call, go to this call. None of that's happened because there ain't no calls because there's no code. So you didn't patch machine code when you loaded and linked. You just patched all the signatures. So now the interpreter can go make calls from this guy to that guy to this and back and forth and whatever, that all works. The thing that you might think of as a classic link or dynamic link patch, whatever, that happens in C2. When C2 generates code and then he has to from here call to there, that's coming along lazily as code gets generated.
Oh yeah, I think I understand now, but I think I also have to restate my question because I probably just confused everyone. But I got my answer, unless you guys really want to know what I originally was trying to ask.
I think we're looking for conversation topics now.
Okay, I'll just ask the question. Okay, so to get around poor build times in C#, what my previous jobs did, they all had project files that would just build one DLL, and it would only have to like compile like a couple 100,000 lines of code. So our main, whatever we're working on, we would only have to compile like 100,000 lines or 200,000 lines. So this kept the build time short. Now I understand that loading dynamic loading the classes is fast, great. But do people tend to separate their Java projects into different modules to keep compile time low? Because people are telling me that their C++ projects can get 20 minutes to an hour. And I heard a couple of cases that got slower. But for Java, you guys were talking about how they had a lot of dependencies. And I just don't know how long compiling all that takes. And if I change one line, how long does it take?
You don't compile the dependencies.
That's the difference. You do not.
So okay, so you for the most part you can change whatever code you want, and it's not going to rebuild that much. Okay, good.
At the time you launch the JVM, the compatibility between the different jars is checked as the jars get loaded, and that's pretty quick. Right?
Oh, so
here's
do you
another.
just like?
Go ahead.
So you just like do some kind of like check if the file has been changed, and if it hasn't,
No.
Oh.
You're not rewriting any code. The amount of work involved is way less. You're checking signatures. You're checking that the link things are compatible, which literally is checking signature strings. So when you load a jar, that's just disk, boom, pile of bits. Then when you start linking classes, it's all incremental. When you start linking a class, he does a signature check, and he walks the class structure for the verifier. When the verifier says this pile of bytecodes is sane, and that's pretty quick. And that's a one pass linear sweep over a modest amount of stuff. And then it's just signatures after that. This guy over here from this other jar says, I want com.cliffc.org. blah, blah, blah. And this guy over here says, well, I'm jdk.java util lang. And that guy over there says, well, I'm apache.commons. Whatever. There's a fucking string involved. And I look for this string over there. And in my string, it says, I need a function that takes a string and takes an int, returns a string, and you give me the name function with the name string. I'm done. So it's this really simple string matching, lazily done as classes are loaded. So another thing happens here in these giant ass projects of everybody is there's miles and miles of dead code, more so in Java than in C, but there's tons of it. And that is, I have a library, I sucked it in, I need this little piece of the library, and 90% I never look at. Well, then the never look at means it never linked. And it might not have ever loaded either. It never came off disk. So the link times is only on what you're using, not
so it'll verify at the class level. So any class you need anything out of, it'll in Arter, you can probably verify or tell me I'm wrong. Any class it needs, it'll verify the whole class, but the linking actually happens at a method level. And that's what Cliff is talking about. It's all lazy.
You check that the class will link, you link other class. There's a separate method level linking that's a handful of ops. I'm not counting this too quick. You do a method level. Sorry. Go ahead.
Linking happens on individual bytecodes. So if you never execute some invoke bytecode, it won't even like link and resolve this symbolic reference.
Right. You have to actually execute it too. Yeah. It's not that it's available on the command line or in the jar and the jar got touched. Or in the class, you link the class, but then you don't do any more inside of the class unless you run it. Yeah.
So with all of this, Java is surprisingly dynamic language. Like it might seem and feel like a pretty static language and not like nothing similar to JavaScript or Python or whatever. But when you have to implement it, suddenly there are these things that happen lazily, happen only when you touch things for the first time.
And there's also a lot of concurrency and concurrent algorithms to allow parallel loading, linking.
And the spec is actually written that precludes an implementation from checking before it's executed as well. So you won't get linker errors until you actually go in and hit the code that would be subject to the linker error.
Have to actually execute it. Yeah.
And that's part of
that's annoying.
It's annoying for the implementer, but it's actually it makes a lot of things amazingly resilient.
As long as I don't call this function over there, I don't care that the library is not available.
So I'm assuming most of the compile time is just looking at the source file and looking at what you imported.
You're talking two different compilers again. You say compile time. Java C looks at source code. The JVM never looks at source code.
Okay, so what's the slowest Java C has ever gotten? Or I mean, how slow can it get if you have a large project? Like, are we talking about the minutes, or is it always like many seconds? I'm talking about like more than a million.
Like I said, it's tens of thousands of lines per second. That's what the number was 4 or 5 years ago, maybe.
Java C. Yeah, maybe.
For the Java C.
And it's actually so the biggest problem with Java C is that it tends to be its own process. So it used to be 3 seconds to compile Hello World and 3.5 seconds to compile your entire library of 100,000 lines of code, because most of the overhead for the JVM was starting up and all the stuff Cliff is describing and so on. And they've taken that number from about 1.5 seconds down to about 0.02 seconds, I think. Arthur helped me out. Am I close? But
that sounds right.
So it used to be if you had to compile things individually, like if your build file said compile this Java, it would be 3 seconds a piece, right? That was 25 years ago. But if you gave it the entire directory and say, build this entire tree, it's like 4 seconds or 5 seconds, right? So, so a lot of application build scripts aren't very good is what it boils down to. And then it's not very good. And then you combine that with something like Maven or Gradle or Ant, and you're just in a world of hurt. So
Yeah, that's your build times. It's not the actual. If you
Right.
make your
I don't want to talk about build systems, but I don't know why people are using like Gradle and Ant and all of that, because one would hope you could just stick to the compiler, but I guess people want something more complex.
it's about reproducibility, and it's about not having every team member have to be an expert and have how to build something by hand. So it's a reasonable goal. It's just that the people behind Gradle, for example, are psychopathic.
Yes.
Oh shoot! This isn't going to get. This isn't going to
see
get
the
posted
camera mental
online. Is it?
pain. See the camera mental pain when he closes his eyes. So
They're actually decent people. It's just that they don't
They've
really
gone
understand.
Yeah, they've gone down some crazy path, a long ways down some like insane. What the hell are you guys doing?
But the build tool has to be more tightly integrated with the compiler in order to understand most of the dependencies, and even then, caching things are still hard. So they're really easy to miss the dependencies because of the way the compiler compiles code. And if you want to be good, you have to be really tightly coupled with the compiler, or
So
at least you have to mentally prepare the compiler to be easy to work with.
But you have to understand too, looking at if you actually look at the IO operations done during a build, and Cliff and I have been exposed to a little of this over the past few months, but one of the things that happens when you build, let's say you have a file called hello world.java, and you say, I want you to build that, right? It doesn't actually do anything with that file, because what it does first is it goes off and it creates another directory somewhere else, and it copies like the entire JDK into that directory. Then it copies your entire source tree into that directory. Then it copies. I didn't say any names.
Okay, let's say
but
I'm not doing that shit.
But that's one example.
Hypothetically,
I am not doing that shit.
So it basically creates this sandbox of 643 million files that it has to put together just to compile hello world, and then the next time then it may nuke it, and then the next time it has to compile hello world, it does the same thing again.
Yeah.
And
this sounds like includes in C and C++. You have your hello world, but then you include a lot of things, and the resulting compilation unit is actually pretty big.
This one is they're not just including the files, so trying to build a disk file layout shape that matches some particular reproducible thing.
Exactly.
That's not necessary.
Reproducible is key here. But then again, includes are some, at least to me, I understand that as an afterthought. They're just pre-process and then pass it to the compiler. They're like a build step, and they introduce the complexity.
There's another piece to this that the C compilers have had for a long time, which is you can ask for what includes got counted in. And it's make depends, and then there's a make file mechanism to gather those and use them so that you can get include file dependencies for very little effort out of the standard make C++ world.
Oh, you mean split in the dependency tree, which depends on which includes?
When you go compile a C program, you can add a flag that says spit out the includes I discovered.
Yeah, I know.
And the spit out will be in makefile format. And the make files can say pound include all the dependencies I find along the way. Suddenly you get the dependencies for your hello world. You go change the OS, pound include blah blah blah, and it filters down into the whole world somehow. The dependencies say timestamp changed, you depend, go rebuild.
You can also get somewhat similar effect to what Cameron described, although maybe not as extreme if you use compiler cache.
Yeah.
Because C cache is going to create a directory just to reproduce your build, so that the next time you build something, if you change incrementally, you won't have to rebuild all of the binaries you have rebuilt.
But here is the really bad part, because discovering that and tracking that dependency.
As we know, caching is an easy computer science problem. So
Of course.
It's
But
it's
you
it's as
never
easy to solve
encounter
as naming things.
you never encounter a stale symbols. That's it. That you never
move away
encountered.
from the C code and you say, I also want to do these other things that you have to start adding explicit dependency checks on. Hey, I want to grab a certificate. Hey, I want to sign the output binary. Hey, I need an x86, 32, and 64-bit versions. Hey, da 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 da. And suddenly you have a lot more things. And now you do need a build system to track and manage that. There's no question about that. It's what goes on with what I'm seeing out of, okay, build system not be named is like ludicrously bad.
It's the tools that the compiler provides to deal with these things.
It's not the tools the compiler provides. It's the tools of the build system trying to manipulate the world around it.
But
compiler is just one of the tools that manipulates.
You can look at that. There is a wall for the build system that has to cope with the artifacts of the compile process. That's what I mean. The compiler has to expose functions or something to ease that process. Not the build tools has to figure out itself, and you cannot really do much. It's easy to make mistake.
Yes, there's that piece. So the thing that I view when or think about my mental model for how build systems work is that in the end, I want an artifact, which is generally a file on disk, and I trust the OS to give me atomic file stamp correct times between the pieces parts up to some timing fractional granularity, it's fine. And the tools read files and write files. So they take as inputs and they produce as outputs these atomically generatable things. And then from there, I can build all kinds of dependency trees I want, run them in parallel, run them however. And issues like, oh, it broke in the middle and it left crap around. Well, now the build system can deal with the crap and say, you take this as input, you produce that as output. Oh, you died, your output's all untrustworthy, I nuke it. And then there's a bunch of varieties of things to make, like another one is, you said you put this as output, but you also put that as output. Well, I don't know if that's as an input hidden by somebody else. You got a stale turd someone will depend on. That should just be a build error. You can't produce a junky output that you don't tell me about. And the easy fix for that is I build you into a temp directory, and then I pull the pieces out I want, and I nuke the rest. And you're not allowed to depend on extra outputs you produce.
It's actually an interesting overlap, though, between what Levo was asking earlier, because in Java, for example, your compilation unit is the class file, right? But in reality, the way you, well, that's in the spec, it's defined as a class file, as a compilation unit. But in reality, if you want reproducible builds, you want to blow away all the class files and rebuild the entire module, if you will.
There's another issue here that you're not talking about right now.
No,
So
I'm talking about
this one is.
I'm talking about, if I change the A code and then I go and change the B code and I compile the A after changing the A and compile the B after changing, like I can get issues where I have lagging outputs.
The Java C claims he takes care of that for you, and I mostly seems to about it.
I have two comments. So the first one is back when Cameron was saying that this build system that copies the world into a folder.
Yeah.
I actually do that in one case. So when my IDE code commits, it runs a script which copies, it basically copies everything, just because I didn't want to accidentally, because I remember Cameron warning me about not accidentally having some object files that you depend on, but it isn't built every time. So when my commit script will copy everything. So, and there's no build folder. So it will have to rebuild everything to see if it actually works or not. So I dodged one problem by copying the world.
That is more defensive way to hermetically seal the build.
You swap one problem for another. I mean, one of the goals of builds is to build systems, is to go fast to get the correct answer. Both correct and fast. And
this is just on commits, though. It's not every build.
Yeah, no, I'm just saying, if it becomes a slow problem to do Java, then you might ponder a smarter build that tries to be incremental, and you open the door for all these problems that we're whining about now about what the hell happens when it did or didn't compile the right thing, or how do you tell it to compile the right thing, and how do you know it did or it didn't?
Yeah.
How do you
And the other thing is, I just tried right now. I made two C files. I had GCC compile both of them, and then I looked at the timestamp, and the timestamp is newer than the newest of the two C files. So I sometimes have the problem where I build a file in C, and I'm modifying it while it's building. So when I hit run again, it's you guys already know.
I know, yeah.
So I don't know why the timestamp isn't like the newest file it looked at, or the newest file.
An F open, and you started writing. Well, somebody's reading as well, and now the
Yeah.
ship's passing the night. That's an IDE's issue though, because the IDE both builds and lets you edit. So you have to solve that one yourself. Like in
Yeah.
Emacs, if I edit a file and I hit the compile script and the compile's running and I go edit the file again, I know damn well that the compiler picked up before, after, in the middle of my edits. Okay, all right, it's screwed up. Fine.
Yeah, I think I'm going to implement that myself. It's not going to be part of the build system.
And in IntelliJ, when I edit and then I hit the go again button, it starts out by saying, go again what? And I have to like, fuck you, go, go, go. And after 15 clicks of making him go, he finally goes. And by then the timestamps are all squared away. I have complaints about IntelliJ. He used to be smart. Now he's just a pain in the butt. Fine. Do a better job than IntelliJ. It can't be hard.
See, every time I try to find people to tell me their problems with IDEs, they always say IntelliJ and whatever they're using is great. And then I hear stories like this, so it's just like
No. IntelliJ has such a grief problem. Even I don't know. Today I had another one of these cases where I hit the find all button in IntelliJ, and I want to find a file called something node. I don't know, call node or whatever. And I type call node, and it finds 5 or 7 other things that have letters call and node scattered about. And most of which I've never touched. All of those first choices are never things I've ever looked at, touched, nothing. And right there in my face is a file called call node. And why can't you find the obvious thing in the directory I've been working at continuously for the last 6 months? Why are you pulling up shit from some versions of JDK?
So the next version has AI and it includes that feature.
Oh my God. This is like,
I was
right,
joking,
exactly.
but who knows?
Right, this is like the wrong direction. If I go to Emacs, I have the fucking
no, Cameron. Literally today they released some AI companion. Like today I saw it.
Clippy plus plus. It's Clippy Junior or something. It's Clippy had a child, a bastard child. Here it is.
The thing is, and this is the challenge with almost all software is, they start with a list of problems that they're going to solve, and they solve those, and then someone comes along and says, well, I'd like this too.
Yes.
And the thing is, because they didn't think of it up front, or because a different developer's been hired and handed it to whatever, like it's like the design, it's like, okay, the design doesn't do that, so we're going to have to glom this thing onto the side, and they just keep glomming.
And
So it's
they
like
lose sight of the official original reason that still exists and is still a key portion of their value add. And you can't, your normal value add of everyday development goes down and down and down.
Because I think IntelliJ is a brilliant product, but I also avoid 98% of it because that's the glommed on stuff I don't want. So
I'm prepared for a different IDE at some point at IntelliJ's. In the last 2 years, they've added so many things that get in the way of everyday development that it's definitely become significantly more difficult to just do my daily shit.
And
sorry, Cliff, I don't have a Windows machine.
All right, Levo, you broke it real bad, but Cameron's going to say something first, so maybe.
Yeah, so let me share my screen, Cliff, just so I can give these guys I will show you just how brilliant I am.
Yes.
Okay.
Okay, while that's loading, my joke was, sorry, Cliff, I don't have a Windows machine.
Oh yeah, fine.
So this is my IntelliJ, and I cannot figure out how to make the fonts readable.
Exactly.
So if you notice, it's light. It's light on white, but I can actually change this
Yeah.
from the IntelliJ Lite to the IntelliJ
Dark.
Dark. Where's IntelliJ Dark? I can't read anything here. Oops, that's a
Bit by
different one.
7. That's a
I-
little better.
Yeah.
That's
Yeah.
actually that's actually a little
You
better.
randomly fell into a better one.
Is
I've seen
this
this
the
with
new-
Cameron before. He was having all kind of issues.
IntelliJ has a new layout.
Oh, and
No,
they have a
it-
new layout that it kind of comes. I'm with the new layout, but it's kind of
Yeah.
because it removes 90% of the clutter. But then you
Yeah.
can't find, like, I want to pull like 4 things back and get rid of the 90%. And the 90% button is great, but let me pull back 1, 2 things. No.
They made an effort to hide, to reduce the
Yeah.
things you see.
I claim that was a good part of the effort. The bad part of the effort for me was I want to set a breakpoint in this line. So I click. Well, that selected that window of the other windows. I didn't select away. I didn't know why it chose a different window. So that first click did nothing. So I clicked again. And that line has an if null check return null. Oh, he wants to ask me a question. Should I break on the return or the start of the line? Except I unclicked too quick. So he just dropped the window away and it did nothing. And I clicked it again 3 times. Ding, 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 ding. Suddenly, so there's a window flashing there briefly. Click and hold. Ah, it has a drop-down question now. It didn't used to. Now it has a drop-down question. I have to go find the drop-down question and let it, and pick. Fuck you. Just give me the start of the line. And then I hit the line. If I move to return, I'll move to return. No. I have to answer the question. And then it didn't put a breakpoint on it because I have another question. Did you want this to be a conditional breakpoint? How about the empty condition? Is that okay? Can I not have to pick yes or no followed by the condition if I want one? So it went from 1 click, there's a breakpoint, to like a maybe set of 2 or 3 and a maybe delay and question asks of 2 or 3 more to set a breakpoint on a line. No.
Cliff,
What
you're an Emacs user. Why are you touching the mouse?
Exactly, because it's IntelliJ. Because everything on fucking IntelliJ is mouse-based. There are shortcut keys.
Really? Oh,
But to go drag the thing around to get where you want to set a breakpoint on is way more effort now on IntelliJ. So yes, I use the mouse on IntelliJ because it has too many things that need a mouse that I can't do.
I thought you could just jump around to anything and breakpoints anywhere, like easily with like a button to click
I've been
into.
unable to find the mouse click keyboards. I mean, it means memorizing a whole two double sets. I have like 10 keys memorized on IntelliJ. It's not nearly enough to get around like I do in Emacs and then park on a line and set a breakpoint on that line. So I use IntelliJ for debugging. And in that case, I'm mostly thinking and looking. But when I'm trying to work my way through whatever sections, then there comes a time when I had to change 5 files over and find something in the middle. Oh, I know I'm going to fail over here. Set breakpoint there. And that's quicker on a mouse with IntelliJ. Yeah, you're right. On Emacs, I'd have said Control X buffer file name, I'd be at the file, or I'd, Alt dot click and be at the function. And then in the GDB Emacs integration, there's a switch to GDB side buffer and say B breakpoint. And that's.
I'm actually planning to implement DApp supports this month.
Somebody said DApp was working better on Emacs, and I haven't taken the time to go try that. I might yet do that. That might make my life a lot happier. Fine.
I don't know about DApp support on Emacs or NeoVim or anything,
No, it's
but
for Java. It's not the Emacs; it's the Java side of things.
Yeah, so I want to attempt to implement it, but I don't really know how to do Go or Java that well. So I'm just gonna base my supports off of C# or Clang or whatever.
Sure. Now you get it to where you got some kind of IDE going. I'll poke at it a little while at least. See if I can set breakpoints and execute code faster. See if you'll load my giant ass. Well, they're not giant.
Yeah, it
Java
turns.
programs and run them.
I had to rewrite my iterator. I didn't rewrite every line, but it was over 900 lines I had to touch this past week just on the iterator, getting all the bugs out. Because every time I tried to break it, I succeeded. And it was just really confusing. and I had to write 3 variants of the same logic. Just
unit
because.
tests are your friend here.
That's how I figured it out, but there was just so many of them that I wrote that succeeded in breaking my stuff.
Yeah.
It was mostly outdent because you had to like do some negative logic, and you can't easily like reverse. You had to like rematerialize some values, and it was just such a pain. It's done, but who would have known that an iterator was over 900 lines? Like that should not be an iterator. That's something else.
I don't know what you've done and how you got there, but time to think
A
about
lot of states.
All right.
At least all the undos and redos is like one atomic operation that makes logical sense. I got that, but I think I should have just made it much more simple and not try to have a tidy undo and redo.
No, the undo redo have to be really tidy. People rely on them mentally all the time.
Okay, well, I did that, and it's such a pain in the butt. It was the undo logic.
And go again, and if it's not going to be like Emacs will skip some steps unwinding after you go a while. You go 4 ways. If you go unwind, it's character keystroke by keystroke unwind until you've gone a long ways, and then it starts to unkeystroke by several groups at a time. But that's after you've gone a while.
Oh, yeah, I don't know about that.
Okay, but every keystroke you went forward, you unwind keystroke back. Yeah.
The way I do it is similar to Chrome and VS Code. It's if you hit undo, the last word is like taken away.
No, not in Emacs, not right away. You go a while before you start to undo chunks. Because it's not necessarily where you don't necessarily end up exactly where you want. And when he does do chunks, you can stop and go forwards again. So if you undoes too big a chunk, you can go forwards to collect the chunk effort back. And then when he's undoing in chunks, it's generally words, and then it's paragraphs or sentences in paragraphs. He does it in logical units, going backwards.
Would you want it to be character by character? Because I always want it to be like a group, like either all my tokens, I mean, all my operators or all my letters, or
Mistype a key, I just want to undo and go forward again. Retype the correct key and go forward.
I just use
I'm slamming out code, and there's 90% correct and 10% miskey or something. I don't know what, and so I have some undos. My fingers have gotten trouble with the new keyboard spec. I can't get a tighter keyboard. My fingers are used to a tighter keyboard, so I miss key a lot until I can get a tighter keyboard. I think I have to spend big bucks on a custom keyboard to get a 17 millimeter pitch instead of an 18 millimeter, 19 millimeter pitch. So
I have no idea. I never felt the difference between that. Like I mean, I need to try that because I don't know what the difference is.
Well, you grew up in an era when they've already locked into 19 millimeter. When I was growing up, there were keyboards had a much more variety of sizes. And for whatever reason, my brain muscle memory locked into somewhere between 17 and 18 millimeter. And I have issues now. That's what it is. All right. I'm going to wind you down.
I'm assuming you don't type on your keyboard violently.
I don't try to break it. I grew up on IBM punch card keyboards and Selectric things, and they required a fairly heavy muscle pressure. So I do hit the keyboard hard because I'm just used to it.
Okay, because I thought
don't play this, grip your hand and do this thing with me either. You won't be happy.
I thought that that kind of style makes you use whatever size you want. Just bang everything.
Well, no, I banged hard the wrong key. So I banged the undo. I got the undo pretty hard. And this is like kind of more new, but it's when I switched the last go around of keys, I gave away the better last smaller keyboard I had to somebody, child, and never saw it again. And then, years later, like, I need a new keyboard. And I went to go get one, and I could not find a 17 millimeter pitch keyboard. Just could not be found. Fine, done. All right, anything else? Anyone else want to do something?
No, but I've been thinking lately with the last few CCs, because we're maybe spinning wheels to find topics. Maybe we can start to all the next CC open with the section of the compiler. Maybe we can start with what our lectures are. Maybe dial down the material, and at least
Sorry, I misunderstood. Start with the
the
compiler.
lectures, what a lecture is, maybe for the next CC, what is a parser? So then maybe
Oh,
kind
you're
of
talking about the
the layers,
fundamentals.
the
Yeah,
layers
right.
of
Well, that would be
the
like walk through the simple project chapter by chapter as a
something like
opening.
that, and not devote too much time on it, but maybe everyone here can share his thoughts, and
Yeah.
maybe we can try it to see how it goes. So
If you want,
um,
I'll bring it up next go round.
yeah.
We did one on memory a couple times that came out of simple, and now chapter 10. Divindu's done what he wants to do with it for now, and I'm just starting to take a look at it. See
Yeah, it's certainly simple. Is very interesting project. I'm
Right. Yeah, Lebo, yes. Yeah.
I'm kind of really soon to explore it. They're really
something.
nicely laid out.
Right. Simple at least has the advantage that it's got chunky sections that are good for about an hour a shot, and has sort of very simple code implementations of obvious things.
Yeah.
And we can talk about why I hate lexers. And Divindu absolutely had to have a lexer, and I was like, you never need a lexer. What the fuck are you talking about? So there it's in simple, the not quite half a lexer.
So
that's a reasonable topic to talk about.
Yeah,
why
everyone
do you care about
has an
lexing or
opinion.
not?
Yeah. So maybe we can start with the concepts related to compilers. So we can devote it maybe 10, 15 minutes, and even the conversation can expand. So we can start with lexing, parsing, type checking.
I got the suggestion. Sounds good.
Yeah.
I want to hear more about compiler tools. Like, I'm not talking about build systems, but I was using Tidy a couple of days ago just to clean up my source code after my iterator refactor. It found like two things, but it's very basic two
Find
things.
bugs for Java and its follow-on products and things like that are all nice tools.
I know LLVM has a lot more tools. I just don't know about them. So I kind of want to. Well, I know the optimizing ones. Like the other week, I was messing around with I think it's MCA, Machine Code Analyzer. That was a fun LLVM tool. Okay. And I never heard anyone talk about it. But yeah, that was nice.
Go present for 10 minutes, and that would give us an hour.
No, I don't know enough about it. I just looked at it a few times.
Okay, fine. Yeah, this is the problem. Yeah, you want to run a group that does something. Well, somebody has to always bring up topics.
Yeah.
All right. Well, let's wait till next week and see what happens.
Yeah.
Yeah. See you guys.
All right, bye.
Yeah. Bye, guys.